Friction. What is friction? That is how we walk. So the force of gravity, as we saw that something is placed on the table, the force of the gravity we have, and why this body is at rest, why it is not moving, there is some force, something which is holding this body. Of course the gravity is there, there is a force also, but when you push it, very mild force if you apply, then you see that it is not going to move. Why it is not moving with mild force? You are applying some force, it is mild force, but the net force is zero. But when you apply certain more force, this is going to move. So when a body is at rest and there is a force applied and this is not moving, this force, which is say impending force, or the force which is stopping this to move, not allowing it to move, this is called Fs, or static force. But when you press with some more energy, this is going to move. So the force which is now impending or trying to resist this your energy or this movement of this body is Fk. S is for static, and this F sub k and F sub k. So this S and K stands for static and kinetic. So static and sliding forces you are seeing here. Fs is parallel to the surface of the body in contact with the table. This is frictional force, or you can simply call it as a friction. And there is a subscript, as I said, that when it is moving it will be Fk. So these are the impending motion of the body in this case, which is opposed by the static friction. And when the external force exceeds the maximum limit of static friction, the body begins to move. And once the body is in motion, it is subjected to sliding or kinetic friction, which is Fk, which is again opposing the movement. And this kinetic friction Fk is generally less than Fs. As you see here, Fs, you are applying force but it is not moving, very little force. When you are applying more force, it has started moving. Now the Fk becomes less than Fs generally. And when there is no force applied, as I said, there is no friction, means no static friction. It comes into play when you actually apply a force. So this Fs is what it is opposing. So that is why we are calling it as a static friction. The body is kept at rest. This is the impending motion. This Fs max is at what point you actually push it and it starts moving. So Fs max is that static friction max, and this force is the maximum force that can hold that body, beyond which if you apply the opposite force, the body is going to move. So Fs max is first of all, it is independent of the area of the contact, but it varies with the normal force. So this is directly proportional to the n, that is the normal force. So we have this mu s. You can say this Fs is directly proportional to n. So this proportionality sign can be changed to mu s. This is the constant of proportionality, and we call this mu s is the coefficient of static friction. And the law of static friction, this can easily be written as Fs, because this is about maximum. When you talk about normal Fs, that is F sub s, that is static friction, it is less than or equal to mu s n. When it becomes equal, that means you are trying to judge the maximum static force. So if the force you apply, or the applied force, exceed this Fs max, the body is going to slide. It starts moving, below which it is not going to move. And the friction force that is opposing the motion is called the kinetic or sliding friction, which is known as, which we represent by Fk. And again, the kinetic friction is also independent of the area of the contact, and nearly they are independent of the velocity also. Now what Fk has, Fk is similar to the Fs, so it is also directly proportional to the normal force. So we have this mu k as the proportionality constant, and this is known as the coefficient of kinetic friction. So if we apply, say, some F force, let us see here. If we apply some F force, this is Fk acting on the other side. So F minus Fk will be equal to what? Ma. The resultant force will be equal to mass into acceleration. So acceleration will be F minus Fk by m, which is given by this. And if we have a constant velocity, this acceleration will be 0. This whole will be 0. So F minus Fk will be eventually be 0. So F will be equal to Fk. Okay. And if the applied force on the body is removed, the acceleration is minus Fk by m, because the body is going to eventually stop. So the laws of friction, which we just saw, they do not have this one and this one. They do not have any fundamental. They are not fundamental laws like those for gravitational and electrical and magnetic forces. They are just empirical relation that we will be using to solve our problems. So when two bodies are in contact, each experiences a contact force by other, and friction, as we said, by definition, the component of the contact force which is parallel to the surface. Again, if this body is kept, or some car is moving, some sort of body is there, so this contact, this is the friction which is acting on it. This is a relative motion basically, because the frictional forces is opposing. Okay, if a box is lying in the compartment of a train which is accelerating, we have friction. So all these are in the examples, these are all the examples of Fs and Fk. Let us take an example, you will understand it better. Determine the maximum acceleration of train in which a box lying on its floor will remain stationary, given that the coefficient of static friction between the box and the train floor is 0.15. In this case, the acceleration of the box is due to the static friction. Okay, so force is what? M into A. So what this will be? We know that Fs is less than equal to mu s n. This already we know, this expression. N is what? This is normal force. So if this is the normal force, what will be there? That will be equal to mg. Let us put mg in this case. So ma will be equal to mu s into mg. Gets cancelled out. A will be equal to, or A will less than equal to mu s into g. Mu s is also given, g is also given. Just multiply them. This will be 1.5 meter per second square. In this figure, a mass of 4 kg rests on a horizontal plane. So it is resting, it is not moving. The plane is gradually inclined until at an angle 15 degree. With the horizontal, the mass just begin to slide. So initially it was like this, then it was taken up this one. So it goes like this. When it reaches this 15 degree, the mass would slide. What is the coefficient of static friction between the block and the surface? So we have certain component we have to make here. The forces acting on a block of a mass m at rest on an inclined plane are what? First of all, we have this weight mg. There is a normal force. Normal force always act normal to the surface. So if this is a surface, this will be the normal force. Okay. Then we have this Fs. This is also acting, which is the impending force, static friction force. So because it is at equilibrium, the resultant force or the resultant of these force must be 0. So if this is mg, if this is theta, this will also be theta, by trigonometry. If this is mg, this will be mg cos theta component, this will be mg sin theta component. So if these are all in equilibrium, so Fs has to be equal to mg sin theta and has to be equal to mg cos theta, which is done here. But as we increase the theta, this self-adjusting frictional force Fs increases until theta is equal to theta max. And theta max is what? It is given that theta max, the maximum angle, is 15 degree. So this Fs max is, we know that Fs max is mu s into n. This tan theta max is equal to mu. We just have to divide these two, this one and this one. And theta max will be tan inverse mu s. Okay. When theta becomes just more than this theta becomes more than just more than theta max, there will be a small net force on the block, and this is going to slide, and theta max depend only on this mu s, and it is independent of the mass. So what will be the theta max? It is given as 15 degree. So you can always find mu s by putting 15 degree here. This is equal to 0.27. What is the acceleration of a block and the trolley system shown in this figure? If the coefficient of kinetic friction Fk between the trolley and the surface is 0.04, and what is the tension in the string? We have to take G equal to 10 meter per second square. So this is the whole scenario. You have a trolley system. This is a block, and we have a trolley system here. This is a trolley. So we have, when it is moving, we have Fk as the opposing force, that is the surface force because it is moving, so we have Fk. This is 20 kg, this is tension, and the same tension will be here because this is a pulley. 30 Newton or 30 Newton will be the force, that is because of gravity. So let us make the free body diagram of these 2 points. First we'll make this one. So we have a tension here, so T tension is given like this, and of course 30 Newton is acting downwards. So T minus 30 is the actual force which will give you mass into acceleration. Mass is 3 kg. So 30 minus T equal to 3 into A. In this case, we have tension here, which is this one. Fk is opposing, and this is 20 kg. So this T minus Fk will be equal to m into A. Mass in this case is 20 kg. So T minus Fk will be 20A. And we know for this Fk, what will be the Fk? Fk will be equal to mu k into n. This we already know. Mu k is given as 0.04. Put it here. So n will be simply 20 into 10. That is 200 Newton. Now put these value Fk we have found out in this, and this gives you another scenario. We have to just solve these 2 equations. We get acceleration and